The past 12 months, 2024-2025, have witnessed significant anomalous solar activity, markedly elevated above the baseline of the previous decade. Recent solar activity, particularly between May 2024 and May 2025, exhibited extraordinary peaks. A noteworthy episode occurred in May 2024, termed the Gannon Storm, featuring an unprecedented sequence of solar flares and geomagnetic disturbances. During this event, NASA documented 82 significant solar flares within a week, including 9 classified as X-class, the most potent category of solar eruption. Sunspot numbers in August 2024 reached an average of approximately 215.5, the highest recorded in 23 years, significantly surpassing typical peak values observed during solar cycle 24, 2010 to 2020, which rarely exceeded 150 sunspots per day. The intensity and frequency of recent coronal mass ejections, CMEs, particularly the May 2024 event with a DST index reaching 412 NT, further underscore an anomalous departure from previous activity levels. When placed against the backdrop of the previous solar cycle, recent solar events represent a stark intensification. Solar cycle 25, which has caused some surprises, was initially projected to mirror the moderate intensity of solar cycle 24. However, the observed peaks and anomalous solar disturbances challenge these early forecasts, hinting at a possible entry into a more active and potentially prolonged phase. Historical comparisons, particularly against the previous decade, demonstrate that both the magnitude and frequency of recent events, such as recurrent intense X-class solar flares and geomagnetic storms with significant infrastructural impacts, are exceptional. The sustained high proton flux and intense eruptions observed throughout this period indicate a potential shift into a more active solar epoch, possibly related to deeper solar periodicities, such as the Gleisberg centennial cycle. Several hypotheses could explain this pronounced shift in solar dynamics. One prominent theory is the potential entry into a more intense solar cycle phase, linked to the Gleisberg cycle, a centennial periodicity that modulates solar activity over approximately 80-100 years. Recent scientific discussions suggest the current heightened activity may indicate the onset of such a phase, characterized by sustained elevated solar phenomena. Additionally, solar magnetic field dynamics, particularly within the solar interior and at the tachocline region, where the solar convection zone meets the radiative zone, may have entered a period of heightened instability or reconfiguration, thus prompting greater frequency and intensity of solar eruptions and magnetic disturbances. The interplay of magnetic reconnection events, particularly in areas of complex sunspot groups such as AR13663 and AR13664, likely contributed significantly to the observed spikes in solar flare activity. The implications of recent anomalous solar events extend beyond astrophysical curiosity, impacting terrestrial and spaceborne technologies significantly. During the May 2024 geomagnetic storm, satellite communications, global positioning systems, GPS, and electrical power grids experienced noticeable disruptions. GPS positioning errors exceeding 1 meter were reported, critically affecting precision-dependent technologies such as agricultural guidance systems and aviation navigation. Moreover, ionospheric disturbances correlated with these solar events have profound implications for radio wave propagation, affecting communications and radar systems across multiple sectors, including military, aviation, and telecommunications. The extreme geomagnetic fluctuations also pose increased risks for induced electric currents within long conductive infrastructures, notably high-voltage power transmission lines, potentially leading to large-scale outages. Given the projected continuation of heightened solar activity into mid-2025 and potentially beyond, strategic responses and preparedness become paramount. Enhanced monitoring capabilities, leveraging advanced satellite networks and ground-based observatories, must be prioritized to anticipate and mitigate disruptions effectively. Infrastructure operators and space weather response agencies should update contingency protocols, emphasizing resilient designs and quick response capabilities to mitigate damage from future solar events. Furthermore, interagency collaboration between space agencies, the unprecedented solar and geomagnetic events of 2024 to 2025 signify a notable escalation in solar activity, with substantial implications for technological infrastructure and scientific research. While indicative of potential entry into an intensified solar epoch, the precise nature and duration of this phase remain uncertain. Proactive scientific investigation, combined with strengthened international coordination, will be crucial in navigating and mitigating future solar-driven disruptions.
Earth's magnetic shield is being tested like never before. Massive solar eruptions, rare plasma storms, and record-breaking sunspots are reshaping space weather in real time.